Okay, guys, so here we are, continuing in IS number 15, part 2, about how many states you can name. So hopefully on the version of this document that you have, these values are actually typed out, and then this part about see the list from above previous class is typed out. But I wanted to point out that we did circle quantitative because this data is quantitative. And then we filled in the sample size, sample mean, standard deviation, and I just sketched the dot plot real quick. I suggest you do the same thing. It's good practice to remember how to make that dot plot again. Okay, so now we have all the information we need to get started on constructing a 95% confidence interval to estimate the mean number of states an intro stat student can name. And again, it's 95%. So we're gonna follow that 4-step process again, the state, plan, do, and conclude. And it's got literally the same directions from confidence intervals for proportions. So we're just going to discuss how things are different for means. So first of all, we're going to state the parameter that we want to estimate and the confidence level. So we are trying to estimate mu, which is the true mean number of states. Let's see, the intro to stats students can name in 1 minute. Whew, okay, kind of a long one. All right, and then the confidence level that it asked for was 95%. So we'll go ahead and fill that in. So you'll get to see this on the back, but if I am just doing this as part of a homework problem, I'm using this outline to help me figure out what to write. So I would write state, and then I would say, we want to estimate mu equal to the true mean number of states intro to stat students can name in 1 minute at a 95% confidence level. I just kind of turn this outline into a sentence. Okay, so then the next part is the plan. So we're going to identify the appropriate inference method and check the conditions. So the inference method is where we're putting the name of the procedure. So it's similar to the procedure for proportions, but of course it's not for proportions anymore, it's for means. So we're still going to say that we have one sample, but we're not using those critical values as Z-star values anymore. We're using T-star values. So we're going to say it's a T interval. Say one sample T interval for whatever parameter we have, which in this case is mu. Okay, so then we have to check the conditions. These are those same conditions we've been talking about. Random. We have to check that we have a random sample. And again, whenever we look at this, we want to look back up to the problem to see if we took a random sample. And it tells us we will use this class as a random sample of all intro to stat students. Now, we should know back from chapter 1 that just using the class is probably more like a convenient sample, but for the sake of collecting data, we're going to assume that it's a random sample. Okay, so assuming the class is a random sample, and I want to say of the population. So of all, and I'm going to abbreviate I.S, intro to stats students. Okay, so the random sample condition is met. The second condition, remember, is that 10% condition. So this is where we check that the sample size is less than 1/10 of the whole population. So our sample size we saw was 19, and that is indeed less than 1/10 of all intro to stats students. Let's see, if we multiply 19 by 10, we get 190. There are definitely more than 190 intro to stats students out there. Okay, so then number 3 is about checking to see if a normal model is a good approximation of our sampling distribution. So this is the only one that's kind of different, remember, from the proportions. Instead of checking that large counts, again, we don't know P, so we can't do large counts. We have 3 different choices. So I'm just going to flip back over to look at those choices again. Let's see. Okay, so our population distribution is approximately normal. We don't know anything about the population distribution, so we have to move on from that one. Then n could be greater than or equal to 30. Well, n is 19, not greater than or equal to 30, so that doesn't work either. So the last choice is the sample data shows no strong skew or outliers. And this is where you can see why we made that dot plot in the first place up here. So we look at our sample distribution. Again, it looks like it has a slight skew to the left, right? That's where it's got kind of this slight tail going on out here. But this is a pretty loose condition. As long as there's not a super strong skew, we are not worried about it. So we can go ahead and state that the sample distribution, which is above, shows no strong skew or outliers. All right, and that is all I need for that condition to be met as well. So check. Oh, and I should have put a check here to indicate that was met as well. Okay, so my conditions have been checked or have been met. All right, so then I move on to this do part. This is again part of the outline. You don't need to write out all of these words for your problems. You just need to show the work that goes along with them. So it's prompting me to write the general formula. That is my point estimate plus or minus the margin of error. Okay, so remember that your point estimate for population means is the sample mean. So our specific formula is going to start out with x bar plus or minus, and then we have to remember our margin of error for means. It's again that critical value of t star times your s divided by the square root of n. Okay, so in order to plug the numbers in, we have the sample mean, we have the sample standard deviation, we have n. We need to find t star. So I'm going to write that out to the side over here. I'm going to look at table A3, of course. So what do I need in order to find that critical value? First, I need the degrees of freedom. So if n is 19, then the degrees of freedom are 18, n minus 1. I think that we don't have to write out 19 minus 1. I think we can just write 18 there. And then we need to know the area of the tails. Okay, so our confidence level is 95%. So we could do 1 minus 0.95 and see that 0.05 is the area of our tails. Hopefully you'll start kind of getting used to what those areas of the tails are and you don't actually have to write this calculation out every day. So we're gonna go ahead and look at table A3 so we can find our t-star value. We're gonna line up 18 for degrees of freedom and 0.05 for the area and two tails. Okay, so 0.05 lined up with 18 appears to be 2.101. 2.101. Remember, I can check this with technology really quick. So I'm going to go to second distribution, scroll down at inverse t. For my confidence level of 95%, I have my area of 0.95. So 0.95 plus the area of two tails divided by 2, because I just want the area of the left tail. And then I have a degrees of freedom of 18. Okay. And if I round to 3 decimal places, it would be 2.101. All right, so I've done it correctly. So I'm ready to plug all my numbers in. My sample mean, if I look back up, is 21.632. 21.632 plus or minus my t-star value of 2.101 times my sample standard deviation of 5.69 divided by the square root of n, which is 19. Okay, so again, I can type all of that in at once. Of course, doing the subtraction first and then the addition second to get my confidence interval. So let's do that. We're going to type in 21.632 minus 2.101 times 5.69 divided by second square root of 19. Okay, I think I've got all that right. All right, so I get 18.889 as my lower confidence interval limit. And now I do that same calculation, except I go in and change my minus sign to a plus sign. Okay, 24.37, and if I round to 3 decimal places, I get 375. So 24.375. There you go, there's my confidence interval. All right, but of course, the next part is the most important part. If you don't do this part, you definitely lose points. You have to interpret the interval and the context of the problem. And again, you don't have to write out the sentence. You just would write conclude and then actually write your interpretation. So we start out with that same sentence as always. We are, fill in your confidence level. So 95% confident that the interval from, and again, I'm going to use my units. So if I'm talking about words, I don't really care about 0.889 of them probably. I'm going to round to one more decimal place than the original data was. I'm sorry, I'm not talking about words. I'm talking about states, which are a word. So I'm going to round to one more decimal place. So I'm going to round up to 18.9. So from 18.9 states to 24, let's see it round up again, 24.4 states. Okay, we are 95% confident that the interval from 18.9 states to 24.4 states captures my parameter, and my parameter is the true mean number of states. Intro to stats students can name in 1 minute. Okay, that took a minute to write out, but that context is really, really important. All right, so I've completed my confidence interval. State, plan, do, and conclude. Okay, in the next video, we're going to talk about the big ideas and do one more confidence interval problem.